correctly demonstrates Newton's first law. Let's watch. Newton's first law, an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced force, was demonstrated in that clip because Tony Stark's race car, when hit by Ivan, aka Whiplash, the car did not stop. It kept moving throughout the air until it hit the ground and friction stopped it. The acceleration of an object produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force, and inversely proportional to the mass of the object, is demonstrated in these next two clips. What we're looking at is the time it takes for Stark in his original Iron Man suit to get off the ground compared to Rhodes in his tricked out suit. Here's Tony.
Let's take it outside.
And here's Rhodes. It takes Rhodes just a bit longer to get off the ground than Stark, meaning it's easier for Stark to push off the surface because his suit is lighter. This demonstrates Newton's second law. For every action, there is an equal and opposite reaction, is demonstrated here by the object hitting Tony in the head, and both Tony and the object bounce off of each other.
Now, put that thing back where you found it before someone gets hurt.
Object and Tony are hitting each other in a sense.
In this picture,
Tony is sitting on a donut sign. The donut has a curved surface, meaning the only thing holding on the sign is static friction, a force of friction that doesn't allow any movement. Iron Man is jumping and falling out of a helicopter before deploying his jets and landing safely at the Stark Expo. Here it is. To determine Iron Man's acceleration towards the Earth, assuming there is no air resistance or friction, we can use the guess method.
assuming Iron Man's suit weighs 108.86 kilograms and Tony Stark weighs 70.31 kilograms, which is an estimate I found on the internet, we have our given mass, 179.17 kilograms. The force of friction on Iron Man is 0 newtons, and the force of the Earth on Iron Man is 1,755.87 newtons. Our unknowns are the net force and acceleration. The equations we will be using are the net force equals the force of the Earth on Iron Man plus the force of friction on Iron Man, and the net force equals mass times acceleration. Here's the substitute, and when we solve it all out, we come to find that because there is no air resistance in this problem, Iron Man's acceleration due to gravity was the force of gravity itself.
To get into his original